Today we are going to be solving the palindrome number problem on LeetCode. It's LeetCode number 9. So the description for this problem is determine whether an integer is a palindrome. An integer is a palindrome when it reads the same backwards and forwards. And they want to know if we can solve it without converting it to a string. So an example they give is if the number is 121, then that's true because 121 reads the exact same forwards and backwards. And then if it's negative 121, then that doesn't read the same forwards and backwards because this negative will swap over to the other side and it will read 121 negative rather than negative 121. So we're going to go over how to solve this in two ways. First with a string and then without a string. So with a string, the steps for solving this are first, divide the string into two halves, ignoring the middle character because the middle character will always read the same both ways. Then step 2, compare the characters on the left half with the characters on the right half and return false if there are any differences between these characters. So an example for the number 1, 2, 3, 4, 1 would be take that number 1, 2, 3, 4, 1 and divide it into two strings, 1, 2 and 4, 1, ignoring that middle character of 3. And then we'd go along both strings. So first compare the character 1 with the character 1 on the other string. So comparing this one with this one. That's all good, same character. Then you'd move forward, compare 2 with 4, and now you get a false, and so that's what you would return for that. So what would this look like in code? So what you do is first take this number, this integer x they give, and convert it to a string. And then in a for loop, you would first take that string and divide it into two pieces with string.length divided by 2. And so that's grabbing the first half of the string. And then within the for loop, for each iteration, you would compare the current character in the first half of that string with the character on the end of the string, incrementing the end one forward on each iteration. And so that's going to go through and compare every character on the first half with every character on the second half, returning false if there are any differences, and if it makes it all the way through the string, it returns true. So if we go ahead and run that, we get a pretty efficient solution, faster than most others, and with a better memory usage than most other submissions. So let's go through how to solve this without using a string now. And I've updated the code below, and we're going to walk through how this works. So the first step in doing this without a string is to handle edge cases. And so anytime x is less than 0, that's going to automatically return false, since negative 1 isn't the same as 1 negative. The next step is to create a number reversed that equals 0, and then copy the parameter x to another number called original. And so what you're going to do is create a while loop, and while x doesn't equal 0, you're going to multiply reversed by 10 in order to slide the first digit over. So for example, if reversed was 1, then multiplying it by 10 is going to slide that 1 over to create 10. And then you can add another digit in to maybe make it 12. And so once reversed is multiplied by 10 to slide that digit over, you add in the last digit in x by adding in x mod 10. So if x is 13, for example, and reversed is 1, multiply reversed by 10 to create 10, and then grab that last digit from x, which is 3, and add that to reversed to make 13. And the next step is to make x equal to x divided by 10. And so you'll slice off that last digit from x and make x 1 by doing x equals x divided by 10. And so once x reaches 0 and you took all the digits from x and added them into reversed, then you'll just compare reversed with the original number. And if it's the same, then the number is the same forwards and backwards. So that might be a little confusing. So we're going to work through an example number to show how this would play out. So for an example number 1, 2, 3, which isn't a palindrome, first step, create a number reversed that's equal to 0, and then grab the last digit in 123, which is 3, by doing x mod 10, and then add that last digit to reversed. So reversed would become 3. And of course, in this step, reversed is getting multiplied by 10, but that doesn't matter since it starts out as 0. And so then removing that last digit from x by doing x equals x divided by 10. So now x equals 12, where that 3 is gone. And so now this repeats, where the last digit from x is now 2, grabbing that using x mod 10. And then make that the first digit of reversed by doing reversed times 10. So this 3 will slide over and become 30. And so when you add that 2 in, you're getting 32. And then remove that digit from x by doing x equals x divided by 10. So now x goes from 12 to 1. And now the process repeats, grabbing that last digit from x by doing x mod 10, and then making that the first digit of reversed by multiplying this 32 by 10 to make it 320, and then adding in that 1 to become 321. And then once that last digit is removed by x by dividing by 10, you have x equals 0. And that ends the while loop because all the digits from x have been transferred over to reversed. And now all there is to be done is comparing the original x, that copied value, with this number reversed we've created. And if they have the same value, then you know the number was a palindrome. And if not, false is returned. And so for the example we have, it would be comparing 3 to 1 equals 1, 2, 3. And that would, of course, return false. So let's go ahead and run this. And so you can see we get a very efficient solution, both in terms of runtime and memory usage.